So we're going to do a couple of examples to understand how the velocity field works. Okay. As the example number one, consider the following velocity field. V is equal to x squared plus y squared I minus 2xy j plus xyz e to the t k, and this is all feet per second. And the problem is saying give me the velocity, components u, v, and w. What are they at any particular location? So if we just compare these, remember that v is equal to v of x I plus vy j plus vz k, and this is nothing also can be written as u, this can be v, and this can be w. Now comparing, you see that your u is equal to v of x and is equal to x squared plus y squared, and your v is equal to v of y, and that will equal to minus 2xy. Don't forget the minus sign, that's part of the problem. W is equal to v of z, and that's equal to x, y, z, e to the minus t. That would be the solution to this problem. But just note one thing: you have actually just give me a minute. Z. This is not a 2, it's a z, just in case. The problem is has a explicit function of time. This explicit function of time makes my problem an unsteady flow. So immediately you can see that you're working with unsteady flow. So if in general sense your velocity field is a function of x, y, z, but also a function of time. Okay? So this is problem number one. Problem number two, let's see what it looks like. One, the same thing, same problem, a different function. Example number two. This example, v is equal to xi minus yj, and the same thing, I want to find u, v, and w. Okay, so from this problem, v of x is equal to x. This is your u. Your v is v of y is equal to minus y because it was in front of j. And your w is v of z is a function of 0. Now, this particular example is steady flow. This is steady flow because you can see it's completely time independent. There is no time equation involved here. So here we could say that this is actually a function of x, y, and z. And if I wanted to know the magnitude, maybe you ask for the magnitude, right, of the velocity. The magnitude is nothing else than v is equal to vx squared plus vy squared plus vz squared. We often call the magnitude speed because the velocity is a vector, speed is the just the magnitude. And so it's the squaring all of these terms, and that will give you x squared plus minus y squared plus 0 squared. So that will give you a value of x squared plus y squared. This is your speed. So this is the speed, and this is the velocity. Okay, velocity has magnitude and direction. Okay. Let's do another example. So in this example now, this is example number 3. Sample number 3. And in this example, it's also given a velocity field. You may ask where the velocity field comes from. These velocity fields can come from elasticity development from the fundamental equations, which we may learn later how to do that, how to find it. Or it may come through experimental data where they were able to somehow find that this equation satisfies the data itself. But this represents how the particle over time, when it's moving from point A to point B over space, this is the value of my speed. Okay, so the problem is saying, can you find V evaluated at 9, -2, 1, and 4, and also saying, go ahead and find the magnitude of V. When we ask for the magnitude, we are asking for the magnitude is nothing else than the square root of Vx squared plus Vy squared plus Vz squared. And from here, if you compare, your V is a function of x, y, z, and t. And if we compare this, we see that x is equal to 9, y is equal to -2. I'm comparing this with this. Z is equal to 1, and your t is equal to 4. Okay, so now what we have to do is we have to go to my equation, and just give me a second. Just want to copy this equation here, and I'm going to replace the values. Okay, so if I replace the values that I'm asked for at 9, -2, 1, and 4, it's going to give you 5x is 9, y is -2 squared, plus t, that's 4. This is I, plus 2 times z is 1, plus 8j, plus 18k. So if you do the math, you find that this is equal to 184j, plus 10 times j, plus 18 times k meters second. It's very interesting to point out that this is the dominant term. Vx is dominant. So there's a lot more speed in the x direction than there's in the other directions. So moving in the problem, I want to find the magnitude. So to find the magnitude, change the colors. The magnitude of V will be the square root of each one of the components, each one of these components, and if you evaluate that, that gives you 185.1 meters second. Note once again that the value that I got here is very close to this value, which is actually telling you that this is dominant in the x direction. Okay, the speed is basically dominant in the x. That's the driving force for your problem. Okay, and this problem, if I was going to ask you, is it steady flow or unsteady? Any ideas? Very good. It will be unsteady because it's time dependent. This is an unsteady velocity field. Okay, because it is time dependent, explicit time, you can see it there. Let's do one more example. Example number 4. This is steady flow. Okay, and it says that v is equal to 5 times z minus 3 I plus x plus 4 times j plus 4 times y k f s. You can see that there's no explicit function of time, so therefore it is a steady flow problem. The first question is, give me the speed at my initial condition when I actually start everything. Z is equal to 0. My starting point. So my starting point will be the velocity I basically take is 5 times 0 minus 3 I plus x is 0 plus 4 j plus 4 times 0 k. So that will give you minus 3I plus 4j feet second. That's my initial velocity at my location. This is the velocity. Let me write it down. Velocity. This will be the magnitude, however, will be the speed plus 0 squared, and that would give me 5 feet second, and this is the speed. Okay. The part B of the problem says y and z are equal to 0, but my x can have any value, so make sure that is not 0. Okay. So I am basically saying what happens if I'm basically floating. I want to know my speed only in the x. If I'm changing only the x-axis, the values of my x-axis. So if I did that, again, 5, 0 minus 3 I plus x plus 4 j plus 4 times 0 k, and that gives you minus 3I plus x plus 4j, and note that this would give you plus 0k, but my 0 basically cancels out. 0 times whatever is 0, so I don't need that term. Okay? So this is your velocity. To find your speed, take the absolute value of that. That would give you vx squared plus vy squared plus vz squared. And that would give you minus 3 squared plus x plus 4 squared plus 0 squared. And when you simplify the whole thing, you find this x squared plus 8x plus 25 square root of this, and this gives you feet second. This is the speed. Okay. Speed is the magnitude, velocity is the vector. Okay, let's do one last example. That's the best way to learn these problems, by seeing many different examples, and we can get a hang of this. Okay, so the example number 5 says that v of x is equal to x plus y, vy is equal to xy cubed plus 16, vz is equal to 0. And the question is the following. At what value of combination of x, y, and z will my speed equal to 0? Okay, so my speed will be 0. Okay, my speed will be 0 when the magnitude is actually equal to 0. And the magnitude is nothing else than all the components squared equal to 0. And the only way this can be 0, since it's all squared, these are squared. There's no other way. If these are negative numbers, they're squared, so they have to be positive. The only way this can be 0 is if all of these quantities are actually equal to 0. Okay? So given that fact, we want to make it 0 now. So that means that each one of my components have to be 0. So what I do is I say v of x has to equal to x plus y has to be 0. V of y is equal to xy cubed plus 16 is equal to 0. From here, I see that x is equal to minus y. And then I can plug this inside here, and I will get minus y cubed plus 16 is equal to 0. I will get minus y to the fourth plus 16 is 0. And then from here, I would get y is equal to plus minus 2, ignoring the complex roots. Okay, so the problem says that basically got two options. The first option is when y is equal to plus 2. Second option is when y is equal to minus 2. And if for plus 2, I plug it here, plus this is actually minus. So x will be minus 2. When this is minus, minus becomes plus. So x is equal to plus 2. So the first pair of coordinates is minus 2, comma 2. Second pair of coordinates is 2, minus 2. Okay. This concludes the session of examples for velocity fields.